So, all that stuff you sent over about the radio signals coming from space, really weird ones?
Uh-huh.
Yeah, I gotta say I've been, totally absorbed by it.
Yeah.
These aren't just like the usual random space noise we hear, right? It's more like, well, actual signals or events, but stretched out over seconds or even minutes.
Yeah, that's exactly what's got everyone in astronomy buzzing right now. It's not like the really fast millisecond bursts we usually get from pulsars.
Right.
You know, those super dense spinning neutron stars.
Right, yeah.
These signals, they call them long period transients, or LPTs for short. They actually linger for a while.
Mm.
It's like a cosmic slow burn, you could say. And where they come from has been a real head scratcher. I mean, for years, we just haven't been able to pin down what could be making them.
So, okay, this whole cosmic slow burn thing. Astronomers are picking up these longer signals and thinking, well, that's definitely not a pulsar. But they don't know what else it could be.
Right.
Is it kind of like hearing a strange engine noise, but having no clue what kind of car it's coming from?
That's a pretty good analogy, actually. For a while, all we had were theories, educated guesses.
Right.
But there wasn't any hard evidence to link these LPTs back to a specific type of star or a whole star system. But that's where this new study you were talking about comes in.
Yeah.
The one by Dr. Iris de Ruyter and Dr. Kaustubh Rajwad.
Right.
This research, it's really given us the first solid clue we've had.
And they used a pretty impressive piece of equipment to get this clue right, the low-frequency array.
Yes.
LOFAR.
LOFAR, exactly.
And one of the articles, they described it as like a giant radio camera.
It is, yeah.
Could you give us a little more of a picture of how this camera helped them?
So think of it like this. Normal telescopes, they pick up visible light, the kind we see.
Uh-huh.
But LOFAR, it's designed to capture radio waves instead. And because it's made up of thousands of these fairly simple antennas, and they're spread out all across Europe, it can create these incredibly detailed pictures of the radio sky, especially at low frequencies. So it's like having a giant eye that's tuned in to see these really faint low-frequency radio signals, and it does it with amazing precision.
So using this super sensitive radio eye, they were able to actually zero in on exactly where these specific long-period transient signals were coming from.
Exactly. This particular study looked at a bunch of LPT pulses that were detected back in 2022.
Okay.
Dr. de Ruyter, she was at the University of Amsterdam at the time, and Dr. Rajwad from Oxford University, they took the LOFAR data and traced the signals back to a specific point in space towards the constellation Ursa Major, the Great Bear.
Right.
It's about 1,600 light years away from us, and at first it looked like just a single star-like object.
But a lot of times in astronomy, what seems simple from far away turns out to be a lot more complicated when you get a closer look, right? This single star, it wasn't actually alone, was it?
No, it wasn't. To figure out what was really going on with this radio source, they used optical telescopes, the Multiple Mirror Telescope in Arizona, and the Hobby Eberly Telescope in Texas for follow-up observations.
Okay.
And that's when they found something crucial. It wasn't just one star, it was a binary system. Two stars bound together by gravity, orbiting each other every 125 minutes. A real cosmic pair, you could say.
A binary system. And the stars making up this celestial dance are a white dwarf and a red dwarf.
Yes.
Can you give us a quick rundown of what those types of stars are for anyone who's not an expert on, how stars evolve?
Sure. So imagine a white dwarf like the dense, hot core that's left over after a star similar to our sun, uses up all its nuclear fuel and shades its outer layers.
Uh-huh.
It's basically a stellar remnant, and it's incredibly compact. A red dwarf, on the other hand, is much smaller, cooler, and it has way less mass than our sun.
Okay.
These red dwarfs, they burn their fuel really slowly, and they live for a very, very long time. So in this system, we've got this dense white dwarf and this smaller red dwarf locked in orbit together. What's fascinating is that it's this pairing, and not the usual pulsar systems with neutron stars, that's linked to these unusual radio signals. It really makes us rethink what kinds of stars can produce them.
Okay, so we've got this interesting pair, the stellar heavyweight and the lightweight, and they're producing these long radio pulses. What are the leading theories about how this actually works?
Researchers have come up with a couple of really interesting possibilities. One of the main theories is all about the white dwarf itself.
Okay.
These stellar remnants, they can have incredibly strong magnetic fields. I'm talking way more intense than anything we see in our own sun.
Wow.
So the idea that these long radio pulses could be coming straight from this powerful magnetic field. Imagine these stars with invisible magnetic lines stretching out into space.
Uh-huh.
And when these lines get twisted or disrupted, maybe by the rapid spinning of the stars or how they interact, they release energy. and that energy takes the form of these powerful radio waves.
So it's like this supercharged stellar magnet is flexing its muscles and blasting out these radio bursts.
Yeah, kind of. Now, the second leading theory is about the interplay between the two stars. It's possible that the white dwarf's super strong magnetic field is interacting with the magnetic field of its red dwarf companion.
Okay.
And this magnetic tango, you could say, creates disturbances and speeds up charged particles, which could be what's causing these long radio pulses. So it could be the white dwarf on its own, or it could be a more complex magnetic dance between the two. Right now, they're still trying to figure out exactly how it works.
It sounds like a real cosmic mystery. Why is this discovery so important for our understanding of, well, the universe in general? What's the big takeaway here?
The real game changer here, and Dr. Rajwat said this himself, is that thanks to this discovery, we now know that compact objects other than neutron stars are capable of producing bright radio emission. See, for a long time, we thought that powerful focused radio waves from the remnants of dead stars were pretty much only coming from neutron stars, specifically pulsars. But this finding, it really opens things up.
Yeah.
It tells us that white dwarfs, those other kinds of stellar leftovers, can also be incredibly active and powerful when it comes to radio waves. Think of it like this. The radio waves we're talking about, they're coherent. It's like a laser beam of radio waves.
Okay.
Very focused and powerful, not like the more scattered radio noise we usually get from stars.
So it's like we've added a new member to the Cosmic Radio Broadcaster Club. It's not just the super dense neutron stars that can do this anymore. That's a pretty big change in our understanding, right?
Exactly. And Dr. DeRuyter, she also made a point of saying that this wasn't the work of just one person or one telescope. It was a big team effort, bringing together astronomers from different areas, using all sorts of instruments and ways of observing the sky. It really shows how all these different ways of listening to the universe can come together to uncover these hidden things out there.
So it's like a team of detectives, right?
Yep.
All working together to solve a really complex case, each bringing their own clues to the table. Now, the articles mentioned that they've seen these long-period transient signals before. How does this new discovery about the binary system help us understand those other signals?
That's a key connection. Over the last few years, other groups have found about 10 of these systems that emit these long-period transient radio signals, but they weren't able to say for sure whether the source was a white dwarf or a neutron star in those cases. This new study, it's the first time we can definitely say that an LPT source is a white dwarf in a binary system. So it sets a really important precedent, and it hints that maybe some of those other mysterious signals are also coming from similar white dwarf binary systems.
So this discovery could be the key to figuring out those other cosmic radio signals. It sounds like Dr. Raj Wade is still looking for more of these LPTs, right?
Oh, definitely. He's going through the massive amounts of data from LOFAR, searching for more of these events. He even said that each new discovery could reveal more secrets about these extreme objects out in space and how they create their radio emissions. He's also interested in how studying the radio waves from this white dwarf binary could teach us about the way magnetic fields evolve in white dwarfs over time, which is a big unanswered question in astrophysics.
It's incredible that one unusual radio signal could open up a whole new way to study how stellar magnetism evolves. That's a pretty big deal, right?
Yeah, it is. What's really interesting is how this single discovery connects to so many big questions about how stars live and die, what they leave behind, and how matter and energy behave in these extreme environments out in space.
Okay, let me make sure I've got this straight. So we had these long-lasting, repeating radio signals that were a bit of a puzzle. Now, we know for sure that at least one type of these LPTs comes from a binary system with a white dwarf and a red dwarf.
Right.
The radio signals are probably powered by the white dwarf's crazy strong magnetic field, either on its own or by interacting with its companion star. And this means that other mysterious radio signals we've picked up might also be coming from white dwarf systems, which really changes how we think about radio emission from compact stellar objects.
You got it. That's a perfect summary. It's a big step forward in our understanding of long-period transients, and it shows just how powerful radio astronomy can be in showing us the hidden wonders of the cosmos.
You know, it really makes you think, if these unexpected radio signals can come from white dwarfs, what other surprises are waiting out there? What other kinds of signals or interactions are happening that we haven't even thought of yet?
Yeah.
Maybe this discovery will lead to new and creative ways of listening to the universe and open up whole new areas of exploration in astronomy. Thanks for going on this deep dive with me. It's really expanded my cosmic horizons.
You're welcome. It's been great talking about this.
Absolutely.
These new discoveries, they're always exciting. They really push the boundaries of what we know about the universe.
Yeah, for sure. Who knows what we'll find next?
Exactly. And that's what makes it all so fascinating, right? The universe is full of mysteries.
Well, thanks again.
You're welcome.
Until next time.
Until next time.